So we have this differential equation, and it wants us to find a particular solution, y equals f of x, and we're given f of 2 equals 0. So first let's just rewrite this function. Minus 1 equals x squared. We multiply both sides by dx. This cancels, we get dy equals dx y minus 1 over x squared. We multiply both sides by x squared. Actually, we don't do that because then what's the point of isolating the variables? So what we do is we multiply both sides by y minus 1, 1 over y minus 1. Just gonna write this under here. It doesn't have to be the best quality. So we get our equation here. We get dy over y minus 1 over dx x squared. From here we can integrate both sides because they respect to the same variable. And what we get here is, worst case scenario, we could use sub, but it does equal ln absolute value y minus 1. And we get 1 over x squared. Just write this on the side, I don't remember it off the top of my head. Add 1, so we get negative 1, get negative x to the negative first. Let me write that as a fraction. So we're going to basically evaluate this log or convert it into exponential form. So we get e to the negative, I almost forgot, never forget your plus c's. If you do, you're going to get roasted. E to the negative 1 over x plus c equals absolute value y minus 1. And then we can expand this to e to the negative first. We're using our exponential rules, times e to the c equals absolute value y minus 1. So now, because it's time, e to the c is just a constant, so it's we can simplify this. Let me just rewrite this up here. C e to the negative 1 over x equals absolute value y minus 1. So now, technically speaking, we would expand this into piecewise, but there's an easier shortcut, and that is converting it to plus or minus c e to the negative 1 over x, regardless of what, and that simplifies to y, just y minus 1, regardless of what, a constant could be positive or negative, so it's a bit redundant, so we can actually just simplify it just to c e to the negative 1 over x equals y minus 1, add 1 to both sides, and then we get our constant, not our constant, we get the full function, which is constant times e to the negative 1 over x plus 1 equals y. So we got y equals f of x, except we have this constant to deal with, and that is where we plug in our function value up here. So what we do is we plug in our function value, c e to the negative 1, our x is 2, so it'd be e to the negative 1 half plus 1 equals 0. Subtract 1 from both sides, c e to the negative 1 half is the same as root e, 1 over root e equals negative 1. C, let me extend this real quick. c to the negative 1 over root e equals -1. We want to isolate our constant, so we multiply both sides by root e, and then we get c equals -root e. So now we plug this back into our equation, and we should get our final solution as -root e to -1 over x plus 1. And I believe there's actually a way we can simplify this, since it is an exponential rule, and that will simplify to -e to the 1 over x minus 1/2. If we combine the fractions, we get -2 minus x over 2x. So our final answer should be -e to the -2 over 2x plus 1. And let me really quickly just check that answer. Because this was actually an answer, a question I missed on a quiz. And it wasn't simplified, it was so it didn't have to be, hold up. So that's that. When we plug in, so we found the particular solution. We got f of 2 equals 0. Once we plug that in, we find c. Yeah, and then that's our so in the final answer in the quiz, it wasn't simplified. It stayed as this form: y equals -e minus 1/2 minus 1 over x plus 1. Yeah, and that's our final solution. Just give myself a check mark on the pat on the back. Yeah, that's all. See you guys.